What's up, 8th grade? Mr. Agnos here. In the past couple of lessons, we actually started looking at graphs for the first time this year, specifically graphs of proportional relationships. And so what we're going to do now is start diving a little more in depth and looking at the specific details of the graphs. And one thing we're going to talk about is a concept called slope. And slope is the measure of how steep a line is. So you have a bunch of graphs, and sometimes the line is really steep, sometimes it's not so steep. Sometimes it's going down from left to right. And so we're going to talk about how to measure that and then what that means. So let me give you a quick few examples here. Before we get into this problem, so what I'm talking about is when I go to graph a line, right, I might have a line that's really steep like this. I might have a line that is really shallow like this, if shallow is the right word. I might have a line that goes down. Right? And when I say down, we always read graphs from left to right. So as I move left to right, this blue line is going down. I might have a line that is perfectly horizontal. And I also might have a line that is perfectly vertical, right? So the slope is, it assigns a number to how steep a line is and whether that line is going up, down, and it's vertical or horizontal. So, because we read graphs left to right, the first thing we need to know is that if we have a line that goes up from left to right, it is going to have a positive slope. That means the measure of how steep this line is going to be positive. Okay, and this will make a little more sense here when we actually start calculating some slopes for lines. If we have a line that goes down from left to right. And again, as an example, you can see this blue line up here is going up from left to right, so that we know when we calculate our slope, we know it's going to be a positive number. If we have a line that is going down from left to right, it is going to have a negative slope, right? Another way of saying it is it's decreasing. Okay, this is increasing, right? This one's increasing, this one's decreasing. If we have a line that is perfectly horizontal, well, that has a slope of 0. It's like we're walking on perfectly flat ground, right? So our slope in this situation would be 0, right? This is the kind you like to ride your bike on, nice and flat. And if we have a vertical line, we say that the slope is undefined, that it doesn't have a slope. We actually don't have a number to measure this. And we'll get into specifics of why that is. So we say that a vertical line has an undefined slope. So these are sort of 4 general categories that all slopes are going to be put into. We're going to get a positive number, a negative number. We're going to get 0 if it's horizontal, and we're going to get this undefined, which we'll talk about more when it comes up. Okay, so the first thing we're going to look at is, okay, if I'm given a graph, how do I calculate the slope of the line? In other words, how steep the line is. Well, the way you do that is you need to find 2 points on the line. Now, the cool thing is it can be any 2 points on this line. Now, for this lesson, they give you 2 points, but in future lessons, they're not. So you can see on this graph, they give us 2 points, right? We have this point right here and this point right here. And the way we measure the slope is we say, okay, how many units do I have to go up? And how many units do I have to go over to get from the point that is furthest left to the point on the far right? And then we write that as a fraction. Okay. Now, slope, we always use the variable m. Don't ask me why, but we always use m. And we say that slope is equal to the amount we go up, the blue arrow here. We call that the rise, divided by the amount we move to the right. That's called the run. So in every situation that we're going to look at, we always calculate slope by finding how much we go up or down. We'll see that in a second. And how much we go to the right. Okay. Now, we're always going to be moving to the right because we're reading our graph from left to right. But there are situations where we might be going up or down here. So let's go back and actually put some numbers in here. I got to count how much did I go up and how much did I go over. Now, when you count how much you went up, I don't count the lines, I count the boxes, right? The boxes are what are measuring the space. So I went up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So using this formula here, the rise is 12, and I have to divide that by how much I went to the right. I went 1, 2, 3, 4, 5, 6. So the slope of this line is 12 over 6. Now, of course, anytime you have a fraction, we have to simplify it. Remember, a fraction is just a division problem. Excuse me. So this means 12 divided by 6. So the slope of this line is equal to 2. 2 is the numerical value for how steep this line is. And another way of thinking about it is what this slope says is for every 2 units we go up, we go 1 to the right. And you can actually see that on the graph here. For example, if I were to start at this point right here, I could go up 2 units and over 1, and I'm right back on my line. Up 2, over 1, up 2, over 1. And you see how I'm making a staircase that goes right along the line here. All right, let's take a look at a second example. I gotta put my answer here. The slope of this line is 2. Okay, if I had put 12 over 6, it's gonna tell me my answer is correct, but in the wrong format. And so remember, you have to simplify. All right, the first thing I want you to notice about this graph is that it is going down from left to right. Remember, a little while ago, I drew, the arrow going down, and I said, hey, if we have a graph that's going down from left to right, then we know the slope is going to be negative. That's a big negative sign. So when we get our final answer here, we know that in the last problem, we had a positive 2 for the slope. In this problem, we know we're going to get a negative number. So the first thing you should always do, especially in the beginning here, is let's write that the slope, which is m, is equal to the rise divided by the run. Now, if we were in the classroom, I would have you guys put in this in your notebooks, and then I let you use those notebooks on homeworks and tests. So we're not in the classroom, so on your own, you should probably have a notebook or a cheat sheet somewhere, and go ahead and write m, right? And if you need to remind yourself, you can say, hey, this is the slope, is equal to the rise over the run. All right, let's take a look at this graph. We always start with the point on the far left. So that's this point right here. And this time I'm going down. Okay, and because I'm going down, we're going to use a negative number to represent this value. And once I'm here, I go to the right. All right, so we need to fill in these values here. We need to fill in these values. So once again, count the boxes, not the lines. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And because I went down, it's negative. So this represents a negative 12. So my rise is negative 12. And how much did I go to the right? 1, 2, 3, 4, 5, 6. Same as last time. Okay, so this time I end up with negative 12 over 6. And remember, again, that's just a division problem. It means negative 12 divided by 6. A negative divided by a positive is negative, and 12 divided by 6 is 2. So in this situation, the slope of our line is negative 2. And what that means is we go down 2 units for every 1 unit we move to the right. And again, you can see that on the graph. If I were to start at this point right here, I go down 2 over 1, down 2 over 1. And you can see that this pattern of down 2 over 1 perfectly matches my line. Okay, I'm actually going to make a couple of videos for this unit. This is a really big topic for this year and for next year. Okay, so what we covered in this one, and again, you can watch this video more than once, and you can find tons of videos on slope on YouTube and stuff. Is if it goes up into if a line goes up from left to right, it has a positive slope. If it goes down from left to right, it has a negative slope. If it's horizontal, it's 0. We haven't seen an example of that yet, but we will. And if it's a vertical line, it has an undefined slope. Okay? And then the way we calculate slope is by figuring out the rise over the run. How much do I go up and over to make little stairs on my line? So please watch this video as many times as you need to. What we're going to look at in the next video is what happens when they give me those 2 points, but not the graph. In other words, what happens when I have the coordinates of those 2 points? Can I still calculate the slope of the line that passes through them? The answer is yes, and we're going to see that in the next video. All right, see you guys soon.